All right, here we go. Question 2. All right, question 2. All right, so using this chart here, 1.6, 1.2, 895. You have this. You can go look it up. I gotta go quick here. I'm sorry, guys. So 1.6 billion tons. So if you have 1.6 billion tons, you only get 1.2 pig iron out of it. So when you subtract that, that's 0.4 billion wastes. Okay. Pig iron that could be produced if all of it was used. So if we know we get 1.2 out of 1.6, that's 0.75. That's 75%. If you take 75% of all of it, 800, you get 600 billion. So you could get 600 billion tons of pig iron if you used all of the reserves. What would you use to make steel? So 95% is used to make steel. That's what it says here, 95%. So 95 out of 800 billion is 760 billion. All right. Weight in tons conserved. So this was a good question, I thought. So if you get 0.7 fewer tons of coal must be mined for every 1 ton you recycle. So 70%, right? Or 0.7. So out of every 1 ton of steel recycled, there's 0.7 tons of coal you don't have to mine. So basically it's saying, what if we wanted to calculate based on how much we recycle? 80 million tons are recycled. So if one recycled ton of steel means 0.7 tons of coal must not be mined, right? It doesn't have to be, sorry. Then you have to just take 0.7 times 80. Right, so 70% of 80. So there you go, 0.7 times 80, 56. Okay. 2 environmental problems associated with abandoned coal mines: sinkholes, habitat destruction, water degradation, the acid drain off, heavy metal runoff, tailings, because you take the tailings, the waste from the mines, and they dump them somewhere else. Increased erosion because you're clearing the land, particulate matter. Animals or people could fall in. Methane's released when you mine coal, and fires because of that methane. And then one thing you could do to mitigate that, so the erosion and the water quality and runoffs and all that, trees, vegetation, plants, that's a big one. Block it off, fence it in so people don't fall in, animals don't fall in. You can retain the water from the acid drainage. Like keep it in a pool or a pond, then treat it. You can treat the acid, there you go, treat it with limestone. So calcium carbonate will neutralize some of that acid. Take the tailings from wherever you dumped them, put them back in the excavation site. Recontour the land, meaning fix the land so that it isn't so barren and readily available for erosion. And place gravel on surface to reduce wind erosion. All right. Surface mining is less expensive. You need less people. There's less chance for disasters or accidents. And that's kind of what this is covering. So, it's going to be cheaper because there's less people to pay, less healthcare claims, less people getting injured, therefore less lawsuits perhaps. So all of that would decrease the cost. All right, that was fast. So I can do question 4 really quick here. All right, 2 climate factors that affect rate of soil, temperature. So you got temperature, precipitation, and winds. Temperature, if it's high temp, increases biological activity and decomposition. Low temperature decreases that decomposition. Precipitation, if you have a lot of precipitation, that increases activity for biological activity and weathering, so which could increase the rate of soil formation, but it could also increase runoff, which would decrease, right? So it could do both. If it's low, then it would decrease the rate of soil formation and weathering, and if it's really low, you could get desertification, and that would decrease all types of activity. Wind can carry particles in, increase accumulation, but it can also increase erosion, which decreases accumulation, right? So it depends on how you explain that. A has biotic and abiotic, humus, microorganisms, bacteria, earthworms, roots, fungi, insects, and then just below it would be your chemical makeup of the parent material: rocks, minerals, silt, clay, sand. Right here. Oscar ate every bad carrot. I forget what we said there. But I think Quinn something disturbing about children there. But anyways, your A there is where you have organic and the underlying mineral material. So it's got both. Back to this. Nitrate levels. Give me one reason in agricultural practice. Fertilizer is the number one. I think everybody probably said that. Fertilizer. And how does that elevate it? The fertilizer gets into the ground, percolates, and gets into groundwater. Acid deposition has affected soil quality in many parts. One way acid deposition affects plant health: it lowers pH, so it might die because there's a certain range it can live in. It leaches out metals, so the metals, the cations, can't get into the plants, like calcium, for example, or magnesium, potassium. Aluminum is one that actually hurts the plants, so that's released from the soil, so that can kill them. Increase soils. Okay. Describe one method for remediating soil. Add a base: limestone, lime, marble dust, crush eggshell, oyster shell, bone meal, marble. All of those things, calcium carbonate, CaCO3, reacts with acid to neutralize it. Climate change is far-reaching. 2 ways climate change can degrade soil: increased temperature, decreased precipitation causes desertification. Increased temperature leads to evaporation of irrigated water, meaning soil will get more salt, salinization. Increased erosion and leaching can increase if there's a lot of rain. You can have flooding, which can also waterlog these things and cause erosion. Hotter it is, the faster the organic matter breaks down and won't stay in the soil very long. Longer growing seasons can deplete the soil, and increased temp can lead to desiccation, which is drying out. That's kind of like desertification. All right, I'll talk to you guys again. I'll send a text or through the classroom or email invite for the hopefully Google Meet tomorrow at 9 a.m. All right, see ya.